Good morning, everyone. I hope you all are doing well. In this lecture, I am going to solve some previous year questions of TIFR. Okay, so let me start with 2017 TIFR question. So this is the first question which was asked in the TIFR 2017. It is about the commutation relation. If you know the commutation algebra, then you can solve it very easily. So let me solve it for you all. So basically, this thing is given. Let me highlight this thing. AB is equal to AB commutation is AB minus BA, and its anti-commutation is AB plus BA. Okay. And the condition is given if AB is equal to 0, then how can we write ABC? We have to choose from the option. The correct answer is D. Forget about that. So how can we reach to the solution? Okay. So basically, you have to open up this relation ABC. If you open it up, then you will get. Let me decrease the size. Okay. Sorry. So this is BAC plus ABC, isn't it? If you use the property of the commutation. So then you can get it AC minus CA plus AB minus BA, isn't it? Into C. So you can have, if you multiply it, BAC minus BCA plus ABC minus BAC. Okay. So you can rearrange it to write. Let me do that for you. You can rearrange it like in this way. We can take common BAC plus ABC. I can bring the third one to second, and I can take minus B common from both of the second and fourth term. So I'll get CA plus AC, isn't it? So if you use the algebra, that is ABC plus BAC, and if I use the algebra, that is minus BAC plus, I have just rearranged it. Okay, so I can use here AB anti-commutation as AB plus BA. It says the property says, so C minus B. I can again use the anti-commutation relation of AC, isn't it? And I have in question I have given AB is equal to anti-commutation is 0. So this term is 0. So and I am left with B anti-commutation of AC. And your answer is this. Option B is the correct answer. Okay. Moving on to the next one. The next one is the question about the way from the Fourier series transform. You all have to know what does Fourier series do. Okay, how does Fourier series is defined? So let me briefly tell you about the Fourier series and what are the elements you need to know about this. So in Fourier series expansion, you guys have to remember one thing, that is odd functions and even function. Basically, the even functions are cos denoting term, and the odd functions are sign denoting term. And if I write the expansion, it will go like this: x of t is equal to a of 0 plus summation over n is equal to 1 to infinity an cos nx, okay, within bracket plus bn sin nx. Okay, why it is not responding well? Okay, let me do this. Okay, sin nx. Okay, so let me, okay, give me a second. Okay, yeah, good now. Okay, you have to end it with a bracket. This is the Fourier series expansion of a function. Okay, what does the Fourier series do? If we have a non-sinusoidal function, we can convert it into a sinusoidal function. Okay. So yes, periodic function we say now this function is periodic, this function is not periodic. So in order to convert to periodic functions, we need the help of Fourier series. Okay, and in frequency domain, in time domain, we use the Fourier transform. That's a different scenario. When the question will come, I will discuss about that also. Yes, let us look at the waveforms. How can you choose from the options, right? In order to save your time, I would like to describe more simplistically than that. How can you choose from the options the right answers? Yes, let's see. The the waveform is in the first quadrant and third quadrant. If you mark it well, then the waveforms are in the first quadrant and third quadrant. And you know, for first and third quadrant, we have the sine functions, sine function. Okay, and for this second and fourth quadrant, we have the cos functions. We all know that, I guess. Yes. So from these options, A and B is not the answer. Okay, because it has the cos terms. Now the question is between C and D. The debate is between C and D. What will be our answers? Okay. So if you will see, the difference is the negative sign. Here is the extra negative sign in the option D. So we need to solve it. And remember, for this first and third quadrant, we have a0 is equal to 0 and an is equal to 0. Only bn doesn't equal to 0. That means bn is going to survive. That is the last term is going to survive. That is bn sin nx is going to survive here. So if we do the expansion, so you will get, I have written the formulas, so you have to do it by yourself. Okay, I can do the whole thing explicitly, but I want you guys to do some math problems. Okay. So if you will solve this, you will get the extra factor 2 by pi here, and you get the limit there. So you will get to your answer, that is option number C. Okay. So let me know in the comments if you are getting the answer or not. Okay. So moving forward to the next problem, this is also a kind of a messy problem TIFR is going to ask. So you have to just think logically about these problems. A solid tetrahedron, solid with four plane sides, has the following projections drawn to scale when see from three different sides. Okay, this is the scenario when you see from the left, this is the scenario when you see from the top, this is from the right. Okay, so what does it say? If you will see from the left, you will get like this. If you see from the top, you will get like this. From the right, you will see like this. So the question is, when viewed from the front, its projection will be. Okay, so when you view it from the front, then how its projection is going to look like. So this is the question you need to answer. In order to answer this question, you have to think logically that between these four options, what should be the answer? You can certainly say the option D is not going to be answered because it looks like a rectangle, which is not the kind of a solid tetrahedron. Okay? And the projection may not be look like this. And similarly, when you look at the C option, you will get this is just the top view and it is kind of rotated a little. And the size, if you do mark the size, this is kind of a similar size when look at from the top. And from the option A, it looks like a triangle. So the only option left is option B. So our right answer is the option B. Okay. You have to think logically about these questions. Okay. So nothing to do more in this kind of question. Okay, this is a very important question. I'm again saying in JAM also these kind of questions come, and in GATE also these kind of questions has already come. So you have to think about this question more logically, okay, rather thinking more simplistically. Okay, I'm going to solve this for you. Okay, so don't worry about this. Yes, look at this picture. Let me name it somewhere around AC. Okay, and this is your B point, and the top I will mark D. Okay, it will be right for you guys, and this height is mentioned H. You can read the question. Okay, let me read it for you. A small elastic ball of mass M is placed at the apex of 45-degree inclined plane. So this is 45-degree incline, 45 degree. The ball is allowed to slip without friction down the plane, hit the ground and bounce along it. If the height of the inclined plane is h and the coefficient of restitution between the ball and the ground is 0.5, then the distance AB as marked on the figure. So you have to find out the AB distance. Okay, in order to find the AB distance, we have to do certain things. So here some concept come into picture. The projectile concept, the energy conservation concept. I am going to apply it all in this problem. Okay, let me do the things for you. So in this particular triangle, the triangle DAC, you can see in the right angle triangle. Okay, this is a right angle triangle. I can't do it like this. Yes, this is a right angle triangle. Okay, sorry, I beg your pardon. Yes, the right angle triangle DAC. Okay, we have tan theta as Suppose this length is somewhere around, what is the length? Oh, okay, this is x by h. Okay, this side is h and theta is this angle. So the uh, thing is, and this is tan 45 degree, and tan 45 is equal to 1, x is equal to h. So I have x is equal to h. That means our length, this AC, will be how much? H. This AC will be h. Okay, I have found it as h. Make it a box. Then from the energy conservation, the energy of the ball at this point is equal to the energy of the ball at this point. Okay, at point D and C. So energy at D is equal to energy at C. So at energy, the point D, the energy will be mgh, that is the potential energy, and at point C, I have half mv square. So if you solve this, so you get v root over 2gh. Okay, you're getting v as this. So from the graph, I could draw like this. Let me. Okay, why it is not taking the automatic step? I don't know why it is not responding well. Okay, do not worry. Okay, this thing is goes like this. Okay, so this angle is theta. This is v cos theta is equal to, okay, what is the value of this? I have to consider. Okay. So if I will do the ux, the projectile, so you'll get v cos 45 degree, which is equal to v by root 2. And I know v is 2gh 1 by root 2. So getting cancelled, gh only you will get gh root over. Okay, effect of restitution. So here comes the effect of restitution. Let me enlarge it a little. The effect of restitution, what does it say? Effect of restitution coefficient will be only in the y direction. Will be only in y direction. So ux will be how much? The constant. Because the effect of restitution of coefficient is along the y direction, so the ux that is along the x direction, it will be constant. So E is equal to v2 sine theta divided by v1, which is equal to half. That means v2 sine theta is equal to half v1. So if you will put the values, that is v2 sine theta is equal to your 2gh divided by 2 root over. So you will get, okay, yes, I guess the root over is only, yes, v2 sine theta, v1 is 2gh root over divided by 2. Okay, now it's right. For time of flight, we have the thing for time of flight. Okay, this is kind of fixed. For time of flight, we have h is equal to ut minus half gt square. Okay, and u is equal to v2 sine theta. So displacement in y direction is equal to 0. That is h is equal to 0 along the y direction. That means I have v sine theta into t. Okay, minus half gt square is equal to 0. That means if you will solve this, you will get sorry, you'll get, yes, if you will solve this, you will get t, the value of t you will get as h by g. Okay, okay, then the displacement AB, will be how much? Then the displacement AB, so in this figure we have, okay, where is the question? Yes, the displacement AB will be how much? The displacement AB, so okay, the AB is here, AB, yes. So we're getting the distance CB. So by totaling, we'll get the distance AB. So the distance CB is, what is the, yes, the distance CB. Okay. Okay, CB is how much? I'm getting CB. That is velocity into time. That means GH root over into time is H by G. So I'll get H, isn't it? So the total length, that is your AB. I'll get AC plus CB. I know AC is your H. This is H I will get. So the total length is, the total displacement is 2H. This is your answer. Okay. So see the option, which one is true. Let me show you that. Yes, the option B is correct answer for this question. Okay. So the next one is, it is a very easy problem. The next problem is like this: two masses 3m and 2m are suspended vertically by identical massless springs, each of stiffness constant k. That is your string constant also k. The mass 2m is, the mass 2m is suspended from the mass 3m, and the mass 3m is suspended from a rigid support, as shown in the figure. If only vertical motion is permitted, the frequency of small oscillation of the system. Okay. Okay, we have to calculate from the concept of small oscillations in this question. So let me talk about this. Okay, let me draw some few important things. Let this displacement and this displacement, let me name it as x1 and this is x2. Okay. So we have to calculate the kinetic energy and potential energy. From there, we have to construct the matrix, the identical matrix we have to construct. From that, we can also call it as characteristics equation. From characteristic equation, by solving the equation, we can get the frequency of small oscillation. Okay, let me go through this. So first, the first job is we have to do the, we have to do, what we have to do? We have to write the kinetic energy expression, that is half mv square, you know, half kx square in this case. So half mv square. Okay, so the first one is 3m and the displacement is x1 dot square plus half 2m and the displacement is x2 dot square, isn't it? And similarly the potential energy term, you will get the potential energy as your half kx1 square plus half C, the stiffness constant K for both the springs. So half K, the displacement, the net displacement is x2 minus x1, so x2 minus x1 square. Okay, so if you open this off, so you'll get half K x1 square plus half K x2 square minus 2x2 x1. You can also write it as, yeah, to make the things, to make the matrix look more simple, we can write it as x1 x2 minus x2 x2 plus x1 square. Okay, got it. I guess you got it. And then we have to construct the matrices for the kinetic energy. So the matrices will be 3m 0 0 2m. Similarly, vi is the potential energy matrix, so this will be 2k minus k minus k k. Okay, you got it. Okay, all good, all good. Okay, so the characteristics equation for small oscillation, if you all know this, the characteristic equation for small oscillation, we have Tij, okay, Vic minus omega square Tic, the determinant should be 0. So I have to write this, okay, okay. So the matrix will be T2k minus 3m omega square minus k and k minus 2m omega square and its determinant. So by solving this matrix, we will get the equation. You will get the equation 6m square omega 4 minus 7mk omega square plus k square is equal to g, isn't it? And now you will get the Dharacharya Sutra. Dharacharya Sutra. What does it named it in the Dharacharya Sutra? Yes. So by solving this equation, you can get minus b plus minus b square minus 4ac divided by 2a. You know the formula, right? So here minus b is your minus b. Yes, this one is minus b. So 7mk plus minus b square. B square is your 49 m square k square 4ac. So 24 m square k square, 24 m square k square. Okay, all things are good. So 2 is 12 m square. Okay, 7mk and the root over would be 25m square k square root over, so that will be 5mk. All good. 12m square. So that will be, if I will take omega square, omega 1 square, so that will be 12mk divided by 12m square. 1m and 1m cutting down, so m, this will be k by m. Okay, and omega 1 will be k by m root over. This is a very nice problem. I hope you all are enjoying this. If you choose the negative sign, so you'll get 7 minus 5, 2mk. 2mk divided by 12m square. 1m getting cut. So 6. So you'll get k by 6m root over. Omega 2 is k by 6m root over. Okay. So we got two answers for this. One is your k by m root over and another is k by 6m root over. So where is the, yes, the option number C is the right answer. So for now, I am ending this video with 5 questions out, and I guess tomorrow I will upload a rest of the 5 questions, and I will try to upload the all the questions with concept. Okay, you will get all the concept revised and all the kind of things you need to do the problem solving. Basically, I want to say one thing about the TI5 problem. You have to get your concept visualized and crystallized concept is needed to do all the problems. Similarly, the questions asked from the 12th level concept, and similarly, the questions may come from the, for PhD students, the questions may come from the part of MSc also, and basically you have to cover the core part. Okay, so for now, this is all from my side. Okay, so thank you. Take care of yourself. Keep sharing, keep liking the videos, do comments, and I'll post all the updates in the community forum.